Alright, hello, we're back once again to more Sudoku time. My gosh, it feels like it's been a while since I recorded one of these, but it's not even been a week. Weird, huh? Because yeah, I posted one video that wasn't Rat Run, like 5-6 days ago, I think. Or maybe I didn't post, but I made it 5 or 6 days ago. But it feels like it's been a while. It's been a long week, let me tell you. But we're here. We're live. We're not live. We're recording. And we're ready for some more Sudoku. It's Rat Run. You know how it be. You know how we do. My favorite Sudoku series of all time. It's close to being done, honestly. At least this part. From what I understand, there is going to be at least a part 3. A third set of 10 puzzles. Eventually. Which is really cool. But this part is almost done. We're in Rat Run 18 out of... Well, 20 is going to be the last one of this leg. But anyway, let's get started. So, let's get those rules up. Normal Sudoku rules apply. So, we have to put digits 1 through 9 in every row, every column, and every 3x3 box, once each. Excuse me. The 3x3 boxes in this puzzle are delineated by these dotted lines, because these green lines are something completely different, which we'll talk about. Now, aim of the experiment. Thinks the rat must reach the cupcake by finding a path through the maze. The path must not visit any cell more than once, cross itself, or pass through any thick maze walls. As well as moving orthogonally, Thinks may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So, there's always a good name of those. Other than doing the puzzle, the Sudoku, our other goal is going to be to get the rat Thinks here to the cupcake somehow. So she's going to have to take some path through this maze. She might do something like this, might do like that, go over here, do this, do that. And that would be a valid path, right? It's getting her to the cupcake like that. Another thing that would be a valid path is if she did something like this. This is allowed, right? That's the moving orthogonally rule that we said. But what you can't do is something like that, because that's moving through a rounded wall spot, and that's just not good. That's just not okay for Thinks to do. Teleports. Entering a teleport will cause Thinks to be instantly transported to the matching colored teleport. From there, she can continue her journey. Matching teleports have identical digits, but teleports that don't match always have different digits. So that's why I was kind of avoiding teleports when explaining the path there. So if we go into a teleport, let's say we're going to B here, then we're going to be spat out at the other teleport immediately. And then we might go into C, from there we might go into A, and from there we might go into cupcake. So that would also be a valid path. And other than that, if this was a 3, this would also be a 3. And if this, and then none of these can be 3s, because the green one's already a 3. So that's how that works. Mirror cells. So yeah, this is the rule that I saw that's very interesting. Each row, column, and box contains exactly one mirror cell. The mirror cells may not contain teleports. The value of a mirror cell equals the digit in that cell subtracted from 10. E.g., a 2 in a mirror cell is mirrored on the 1 to 9 scale, and it has a value of 8. Every mirror cell contains a different digit. So if this was a mirror cell and it had an 8, for math purposes, it would actually be a 2. And then because this is a mirror cell, each row, column, and box only contains one mirror cell. So none of these cells in the same row, column, or box would be mirror cells. And that's going to be interesting with the rule that we'll see here in a minute. But before that, one-way doors. Thinks may only pass directly through a purple arrow if moving in the direction the arrow is pointing. An arrow always points to the smaller of the two values it sits between. So Thinks cannot do something like this. That's not allowed, because she would be passing through the arrow in the wrong direction. And also, this digit is bigger than this digit. Or should I say, the value of this digit is bigger. So if that was a 2, but it was a mirror cell, its value would actually be 8. So this would be allowed to be a 7. That's allowed in this puzzle, if this is a mirror cell. Task constraint. In this experiment, the values of any two physically adjacent cells along the path, i.e. not separated by teleportation, must have a difference of at least 5. So, I mean, that's pretty simple, right? Whatever this cell is, whatever the value of this cell is, the value of this one's going to be at least 5 different from that. And then the value of this one's going to be at least 5 different from that. And those are the rules. Yeah. pretty a lot, honestly. But we'll get through it. Now, I think mirror cells may not contain teleports. Okay. So that's one very small thing we can start with. These cells aren't mirror cells. Now, this is going to be a little hard because this rule right here is, I'll explain it more in a second, but it's what we call German whispers, usually. So the line that Finks makes throughout the puzzle is going to be a German whispers line. And I like working with German whispers by coloring cells to make sure if they are below 5 or above 5. But I'm also going to have to denote what is a mirror cell and what isn't. So for now, I'm not going to worry about it. And I'm just going to say I'm going to color non-mirror cells blue. And I'm going to color mirror cells orange. But that's really all I can say for now. Now, one thing we do know is Finks does that. To get started, Finks does that for sure. Okay, now she has 2 ways to go. She might go down, or she might go right. If she goes right, then she's going to go at least to here. Now, 2, 3, 4, yeah. So now what I'm thinking of is let me explain let me explain German whispers for a second. So this rule, adjacent digits must have a difference of at least 5, is the same rule that we would normally call a German whispers line. So the line that Finks makes, it's going to be a German whispers line. Also, maybe I shouldn't draw the line as green, because the puzzle is green. So maybe I'll draw it as pink. Yellow? I don't know. Is there any better colors that I can get? No. No, there aren't. Yeah, I'll just draw it as black. Yeah, you know what? That's fine. Let's just draw Finks' line as black. Now, if she went right, then she would do at least that. So, with a German whispers, what you usually have is, if you start with some digit, one thing, it's not going to be the digit 5, because there is no Sudoku digit that is 5 away from 5. You can't put a 10, and you can't put a 0 in a puzzle, or anything more extreme than those. So, this digit's not 5. So it is either below 5 or above 5. Now let's say it's below 5. Well, then what is this digit going to be? It's not also going to be below 5, because the 2 digits that are the most apart, that are below 5, are 1 and 4, and they're only 3 apart. So this is going to be above 5. And then the same logic tells us this is going to be below 5, then above, then below, then above, then below. In this puzzle, now, the thing we have to understand is that there's 4 digits below 5, 1 to 4. And there's 4 digits above 5, which are 6 to 9. So usually, you can only have 4 digits of the same polarity, is what we call, in a German whispers line. In this puzzle, you can technically have 5 if one of them is a mirror cell. So let's say this is a mirror cell, and it was a 2. Well, this actually is, the value of it is actually 8. So this would now be a high digit. And then these could be high digits. And that would be only 3 of the high digits used, but 4 high values used. But then we can only use 3 low values, because we've kind of borrowed an extra high value by making it a mirror cell. So that is interesting, and I'm thinking of why that makes this arrangement impossible. because I don't think that this is going to be the arrangement that we do. Well, one thing. If this is the arrangement that we do, we then don't go down, because that would cover all 9 cells here, and one of them is going to be a 5. Even if it's a mirror. Even if that 5 is a mirror cell, 10 minus 5 is still 5. So one of them is going to have a value of 5, and like I said, 5 is impossible to put on a German whisper slide. So this definitely doesn't happen. So then this would be forced to happen, and then this would be forced to happen. And then we can't go left, because then we'd cover all 9 of these cells, and that's impossible. So we'd be forced to go right. And from that, well, one thing we can't do then is go into the teleport, because if we do, now how do we get back into this box without crossing our own path? We can't. So we would have to go straight to the cupcake, pretty much. It would either be like that, whoopsie daisy, or like that. So we would have to go straight to the cupcake. And oh, there we go. And then all 9 of the cells in this row would be contained in the line, and one of them would be a value 5, and that's impossible. So that proves that we cannot turn right here. So we do turn down. We go here. Now what? Now we have to remember that we can't cover these 3 cells, because if we do, same thing. One of them is going to have a value of 5, and that breaks everything. So we can't do that. We also can't go over here and then turn, because then we're stuck. We either bump into ourselves, or we go through an arrow that is going the wrong direction. So we're forced to turn right here. Then we're forced to go down. We can't go right, because that's an arrow. So go down, go left, and that's actually forced. That entire part of the path is forced. And now look at this. This is the only cell in this column that is not on the path. So it is a 5. Now, that might be a mirror cell, that might not. Mirror cells on 5s actually don't affect them at all. Because, like I said, 10 minus 5 is still 5. But now what I'm thinking of is there's 2 digits, usually, in German whispers that are hard to place. 5 is impossible to place, but there's 2 digits that are hard to place, and those are 4 and 6. Because if you think about it, what would happen if this was a 4? Let's just not talk about mirror cells for a second. What would happen if this was a 4? Well, we would need both of these digits to be 5 away from 4. Well, the only digit that is 5 away from 4 is 9, so both of those would have to be 9, and that's just not going to happen. In this puzzle, that is technically possible if you have a 4 here, then you have a 9, and then you have a mirrored 1. So this 1 would actually have a value of 9, and that is okay. That is fine. But then we have the same problem with 6, because 6 can only go right next to a 1. So what I'm thinking of is... Yeah. That is actually going to have to happen in one of these spots. In somewhere in these, there's going to have to be a mirror cell, and it's going to be a 4 or 6. Or not a 4 or 6, sorry. It's going to be adjacent to a 4 or a 6. Because if that wasn't the case, then let's think about which of these squares have that problem of we can't put a 4 or 6 there in normal Sudoku without mirror cells. This one you can't, because those 2 see each other. This one you can't, because those 2 see each other. Same thing with all these. This one you can't, because those 2 see each other. This one you can't, because those 2 see each other. And this one you can't, because those 2 see each other. So you can't put a 4 or a 6, usually, in any of these. Now, you can put one of those in there with the help of a mirror cell, but you can't put both. So what I'm saying is that this here is a 4 or a 6, and this is a 1 or a 9. Or rather, it has the value of a 1 or a 9. Now this is not mirrored, so I'm going to color it blue. Because the mirror cell is going to have to be the 1 or the 9 that's adjacent to the other 4 or 6. Now, is this mirrored? Well, this is not mirrored. something I can say. Because it isn't a 1 or a 9. Newsflash, 5 is not equal to 1 or 9. I know. Amazing. Is this mirrored? I don't think this is mirrored. Because if that's a 4, then that has to have a value of 9. So it is either a 9 or it's a mirrored 1. But if it's a mirrored 1, then the mirrored 1 would have to go next to the... if it's a mirrored 1, then the 6 is still impossible. Because the 6 needs to be next to a mirrored 9. So this is not mirrored. This is normal. Now, what does that mean? Well, now comes the problem of I need more colors to mark what is high and what is low. Because I don't know what it is yet. But we do know that even with mirrored cells, the polarity, value-wise, still goes back and forth. It still goes high, low, high, low, high, low, high, low. It's just the digits might not follow that because of mirror cells, but the values are still following that idea. So if this is high, this is low. And then this is high, this is low, high, low, high, low, high, low, high, low, high, low, high. In fact, that is correct, because high is bigger than low. I'm going to tell you that right now, because if this was low, then I go low, high, 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 low. And then you have a low value, which is supposed to somehow be bigger than a high value. That's not going to happen. So this is high. It is a 6. And then this is a 1. Now, this is high. So it is not a 6. It's 7, 8, or 9. And then this is low. Now, this might be our... Can this be our 4? Yeah, this could be our 4 if that's a 9. Wait a second. Did I do this wrong? No. Wait a second. Oh. Wait, what? Well, now I'm wondering how do we put... Oh, that's how. Okay. Now I'm wondering how do we put 4 in here, because the 4 is going to be next to, like I said, a 9 and a mirrored 1. But we already have a 1 in this column, so none of these can be a 1. So one of these two is going to have to be a 1. And one of these two is going to have to be the 4. So 4 is in one of these two. 9 is in one of these two. And there's a 1 in one of those two. So that's high, that's low, that's high. Yeah, okay. So this is a 7 or an 8 is what that means, because 9 is already taken in this column. This is a 2 or a 3, because 4 is already taken in that column. This could be a 9, then that would be a 4, that would be a mirrored 1. Or this could be a 9, that would be a 4, that would be a mirrored 1. One of these two is mirrored then, which means these are all safe, actually. Excuse me. These are all safe, actually. Because one of those two is definitely mirrored. I don't know how to mark that best. But yeah, one of those two is mirrored in that column. Now what I'm wondering is what is mirrored in this column then? Because the 4 is not mirrored. The 9 can't be mirrored. Remember, mirroring changes our polarity. If we're mirroring a high digit, it becomes low. If we're mirroring a low digit, it becomes high. Oh. Wait, why did I say that 5 couldn't be mirrored? Let me go back for a second. Oh, right. I said that 5 couldn't be mirrored because I thought the mirrored 1 was in that column. But the mirrored 1 is actually not in that column, which makes me think that that 5 is mirrored. Because if it isn't, then this column goes high, low, high, low, high, low, low, high. So it does have 4 highs and 4 lows. If we mirror, then that's going to throw off that balance. I'm going to have a surplus of either highs or lows. So I don't think any of those can be mirrored. So I think this 5 is actually mirrored. Which, like we said, doesn't change its value at all. But what it does do is it makes sure that those are not mirrored. Those are all safe, which means this can't be the mirrored one, which means this is the mirrored one. And we go like this. And I think that's correct. Huge. Okay, very good. Very cool. Which means these are not mirrored. That's not mirrored because it's in the same box. Okay. Very cool. Very cool. Now, this is normal, so it is a low digit. It's a 2 or 3, and this is a 7 or 8. This is normal, which means this can't be a 7. Yeah, because if this was a 7, this can't be a 3, because 7 and 3 are only 4 apart, so this would be a 2. But this also has to be at least 4 apart from 7, and the only other digit that's at least 5 apart from 7. And the only other digit that could be is a 1, but we already have a 1 there, so that is an 8. That is a 7, which means that is a 2, and that is a 3. And now we're cooking with gas, dude. Okay. So, remember, that is a high digit. Yeah, so what I think I'm going to do... I'm going to do this. I think I'm going to have 2 colors. So what I'm going to do is I'm going to color these orange, which I said I was going to do. I don't know if I didn't do that. And then I'm going to have separate color for the line itself to denote what is high and what is low. So that's high, that's high, that's high, that's high, because it's a mirror cell. That's high, that's high, that's high, and that's high. And then these are all low, and I'm going to mark them as green. Okay, I think that works, honestly. So again, oranges denote where the mirror cells are. Blues denote where the mirror cells are not. Greens denote low digits. And reds denote... Well, no, sorry. Green denote low values, and reds denote high values. These are all high, so they can't be 1. So the 1 goes there in this box. It is low. These are 2 and 4. Well, that definitely can't be a 4, because 4 is not 5 adjacent from 8. So that is a 4, and that is a 9. These are 6 and 7. That can't be a 6, because 1 is already there. So this is a 6, that's a 7, that's a 2. Okay. We're kind of cooking with gas now. Very good, very good. Now what I'm thinking of is, where the heck do we go now? Because now the puzzle opens up a lot. Because the path might go here and then go somewhere. Or the path might go here and then go somewhere. And I don't know which one of those is going to be our answer, to be honest. Well, one thing I know is we don't go straight here. Because if we did, then this digit would be low, because that's high. And then this digit... Oh, my bad. Much easier way of looking at it. We actually can't go here. Because if we did, then this would be a 1, because that's a 6. And that would clash. So we do go right. That is a 1, because that is a 6, and this is a normal cell. It's not mirrored. And now, what do we do? That is the question, is it not? 1 is down there by Sudoku. That doesn't really help us, to be honest. Yeah, now it becomes hard. Because now, what the heck do? I don't know. Well, from here, I have to go into a high value. So I'm either going to go here, and it's going to be a high digit, or I'm going to go into one of these two, and it's going to be either a high digit or a low digit that is mirrored. And I don't know which one of those is correct. Let me do some pencil marking, because that sounds like a better use of my time right now. These can be 3, 4, 5, 6, 7, or 8. These are not, these are not 6 or 7, which means the 6 and 7 are actually here. They are high. If this is a 3, that could be mirrored, actually. This value has to be bigger than that value. But this could be a mirrored 8 or 9, and this could be a 3, and that works, unfortunately. These, I can put them in, actually, because they are 3 digits that are going in sequence, and they're the only 3 digits left in this box. So they are 3, 5, and 8. And that's a 5, so that's actually a 5. Which means that's not a 5. And then the digits left in this column are 2, 4, and 9. I don't think I can do anything with that, unfortunately. Usually I would be able to. I could remove 2 from here, because 2 is not bigger than 4 or 9. But this 2 could be mirrored, is the issue. In fact, one of these is mirrored. If that's a mirrored... No, I don't know. I don't know how to deal with this sequence yet, unfortunately. If that's a 3, that could be a mirrored 9, and that still works. If that's a 5, that could be a mirrored 9, a 4, or a 2, and that works. And if that's an 8, that could be a 2, or a 4, or a mirrored 9, and that works. So the only way that that can be a 9 is if it's mirrored. That makes sense, obviously. Otherwise, 9 isn't here. And it might be mirrored down here, or it might be normal up here. I don't know. The only place that 9 can be normal is if it's right here. Otherwise, it's mirrored in one of these two. Is what that means. I don't know. I don't think there's any way of disintegrating that yet. But, well, one thing I know is we're never going to the A teleporter now, because it has a 5 in it. And like we said, German Whispers lines just can't go into 5s, so that is out of bounds. Which actually is interesting, because now, how the heck do we enter the final box here? Well, the only other entrance is through here. But the only way of getting there is by going through here. Oh, that's interesting, isn't it? Well, that's very interesting. And then from here, we can't go up, so we go here. And then I don't know. We might go directly here, or we might go up, and then there. But either way, this is a low value. Well, how do we get there? We don't get there through here, because like we said, that 5 is out of bounds. We don't get there through here, otherwise we're stuck. So we get there through here. And because that's a low value, that's green. These are high values. Now, I don't know if they're mirrored or not is the problem. But they are high values. Which means if this is not mirrored... Oh. Yeah, there we go. This has to be mirrored, actually. Because if it's not, the only way it's a high value is if it's a 9. But then, no matter what we put here, even if we mirror it, we're not going to get higher than 9. So this is mirrored. So it is orange, which means these are not mirrored. These are blue. These are all blue. And there we go. So we have another mirrored cell. It is a 2 or a 4, because we're mirroring a low value to get a high value. Then this is low. This is high. Now, we're mirroring a high value to get a low value. We're not mirroring a 1, so the value of this is either 8 or 6. It's not 6, because 6 is not 5 away from 3. So this is value 8, digit 2. This has a value of 8, so the only digit that's bigger than that is a 9, which means that's a 4. Which means we need a digit that's higher than 4, so that's not a 3. Okay. That's cool. Wait, that's cool. Now, this has to be a real low digit. It's not a 4, because 4 is not 5 away from 8. So it is a 1 or a 3. Oh, it's not a 1 actually, because that 1. So this is a 3. Which means that is an 8. That is a 5. And that is a 3. Okay, dude. So now, this has to be 5 away from 3. So it is either a natural 8 or a mirrored 2. Yeah. Because, yeah, this could be a mirrored 2, and that works. It can't be a mirrored 1, it can't be a natural 9. This is either a natural... Oh, this is not mirrored, actually, because if it's mirrored, it would have to be a 1 or a 2, and it can't be. So this is natural, and it is an 8 or a 9. Okay. That's very interesting. This is high. Yeah, this is a high value, so this means we can go up, because that would be a low value. That doesn't work, unfortunately. If we go right, then that's... Well, actually, let me think of something. If we go up, then we're doing this, and then we go high, low, high, low, high, low. So then this is a low digit. If we go right instead, then we go high, low, high, low. So this is still a low digit. So this is always low, actually. And this is always high. It's always low and natural. So it is a 1 or a 4. And this is always high. So it is a 6 or a 9. It's always high and natural, is what it shows. Okay. If this is a 6, this is forced to be a 1. If this is a 4, this is forced to be a 9. But then we're also forced to put... This can't be a 4. This can't be a 4. Okay. Because if this is a 4, then we can't go here, because then that would be another natural 9, and we can't have that. We can't go here either, because then either that would be a natural 9, which it can't be, or a mirrored 1, which it can't be. So that actually can't be a 4. That is a 1. Which unfortunately does not tell us the polarity of that. But we tried. Oh, no, it does actually. Because this can't be a 6. Because we don't know where this is going yet. It might be going here or here. But wherever it goes in one of these two. And then if this is 6, the digit that it goes to either has to be a natural 1, which it can't be, or a mirrored 9, which it can't be. So this is not a 6, this is a 9. Very cool. The remaining digits in this row are 4 and 6. This is so cool. Okay, now the path can't do this, because then this would be forced to be a 6, because it has to be high, because this one's low. But then this would be either a natural 1, can't be, or a mirrored 9, which it can't be. So the path does go over here. And now, where does 5 go in this box? Well, it doesn't, oops. It doesn't go in any of those. It doesn't go here, so it goes there. That is a 5. That's so cool, dude. That's so cool. Now, these are all low. Oh, did I do something wrong? No, it didn't actually. Well then. Because what I'm thinking about now... Yeah, okay. Fair enough. This is a 4. Because these are all low values. But if they were all low digits, then one of these would have to be a 4. Which 1 doesn't work because of the German whispers, and 2 doesn't work because of that 4. So one of these is going to be a low value, but not a low digit. So it is mirrored. So one of these is our mirror cell, which means that is not a mirror cell. That is a natural 8. That makes that a 9. That is natural. These are all natural. Those are natural. One of these is mirrored. Yeah. One of those mirrored. And the 4 can't go in those. It can't go in these because these are high, so the 4 goes there. The 6 goes here. And there is a 9 that has to go to this box still. It goes there. That is now a... that's a 6, actually. which means this is the mirror, because if it wasn't, it would be a natural 1, and then those would clash. So this is a mirror cell. It is a mirrored 9. No, sorry. Did I do something wrong? Oh, it did. Hold on. What did I do? Oh, yeah, my mistake was thinking that this had to be a 9. One of those could be a 9, and it could be mirrored. My bad. Yeah, my bad. Well, the 6, I was correct. The 6 can't go in, it goes by Sudoku. So the 6 does go there. Now, that is a mirrored 9. So I was right. It is mirrored. It is a low value, because its value is 1. That is high. That is high. That is a low value, and it's not mirrored. And so it is a 2. And that is a 7 to complete that box. These are 1, 3, and 8. Yeah. And well, I know we get to the cupcake by doing this. So these have to alternate. So this can't be an 8, because then these would be 1 and 3 next to each other. So that is low. That is high, which means it is an 8. And that is low. And now what we can't do is go straight up, because then this would be a low value, and this would be another low value right next to it. So we go diagonal like this. And now this is a low value. This is a high value. And those are 1 and 3. Very good. This, I don't know, because we haven't put the mirrored cell in these 3 yet, so I don't know what this is. But these 3 digits are 2, 4, and 7. What can this be? This could be... This can't... This is either a mirrored 7, which works, a natural 2, which works. This can't be a natural 4, because then this would have to be a mirrored 1, which it can't be. So this is not a 4. This is either a natural 2, to go together with that 9, or a mirrored 7. Now this is high. It can't be a 4, because mirroring that would give us a 6, and then that can't be a value of 1. So that is also not a 4, so the 4 actually goes here, out of all things. Now, must one of these be mirrored? I don't think so, actually, because this could be a 2, 7, 1. That works, that's fine. In fact, must these both not be mirrored? Yeah, these can't be mirrored. Because if they were, they would be 2 digits of the same polarity. 2 values of the same polarity next to each other. So this is actually a mirror cell. These are safe, which means these are also safe, because they're in the same row, or column. I am not talking well today. My bad. Which means that's a 2, that's a 7, that is a 1, and that's a 3. Very good. Oh, 3 in the corner, look at that. Very cool. Okay, now, we have the beginning of the path, we have the end of the path. How the heck are we going to find the middle of the path? What that looks like? I am not sure yet. Let's see. Well. Oh, my bad. That's a mirrored. So these are all safe. Okay. I think now we've marked all the cells correctly. These colors, I'm gonna be honest, they're getting a little in the way. But we do what we can. I'm trying to keep the yellow and the green and the red only on the path cells. Make it a little more organized, I guess. Let's see. I'm trying to think here. If this moves down, what's going on? This is either, well, if it's natural, it's not a 1, 2, or 3, so it is a 4. If it's mirrored, It's not a 9 or an 8, so it is a 6 or a 7. So its value is either 4 or 3. It can't... Yeah, it can't be a 6. Because then it would be the mirror cell. And then it would have to move to another cell. But that cell has to have a value of 9. So it can't go there, 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 or there. Those 3 by Sudoku, because the 9 is already there. So this would not be able to be a 6. Could this be a 4? Then it would have to move to a mirrored 1. And that 1 would be forced to be there, which could work actually. And if it's a 7, it would be mirrored, its value would be 3, and it would have to move to a cell that either has a value of 8 or 9. Which could be that one. Can't be those two. Could be that one if it was an 8. Okay. I don't think I can disprove that it moves down yet. Oh, my bad. I don't think I can disprove that this path moves down yet, so maybe I need to look over here instead. Or, yeah, what am I doing here? Let me look through something. Did it say at all that every mirror cell contains a different digit? Ah! That I didn't see. Okay, that I didn't remember. So which digits have we used? We've used 1, 2, 4, 9, and 5. Okay. Now, the interesting thing there is that we have used 1, 2, and 4. So it's pretty hard to mirror a low digit into a high at this point, because the only way that can happen is if you're mirroring a 3. Well, now if we move back to that idea that I was having about... about this moving down. We said that couldn't be a that could be a 4 or a 7. Well, now it can't be a 4, because a 4 would have to move into a mirrored 1. We already have a mirrored 1. So if this moves down, it is mirrored and it's a 7. Now we have not used 7 yet, so that would be okay. But then what would happen? It would have to move into a value that has a cell that has a value of 8 or 9. If it goes there, that's okay. But then how does it escape? It must go here. And then this is a naturally small cell, and it's not 1, 2, or 3. So this would be 4 and that breaks. 4 and 8 are just not far enough apart. It can't go here or here, because those both see 8s and 9s, and they're natural. So it'd be forced to go here. And now this cell has to have a value of 8 or 9. It can't be mirrored, because 1 and 2 are already taken, so it would be a natural 8. So if this goes down, it then goes straight right, and this is an 8. Can I now disprove that this moves right somehow? I think that's harder. Let's try. If this goes right, then this has to have a... Okay, what can this be, for starters? It can't be... it can be a 1, it can't be a 2, 3, 4, 5. It could be a 6. Can't be a 7, it could be an 8. If it's 6 or an 8, it must be mirrored. We have not used 6 and 8 yet in the mirror cells, so that's okay. But then what? Well, then I don't know. Then we actually have a lot of freedom. No, we don't. No, we don't. It can't be a 6. It can't be a mirrored 6, because then you would have to go to a natural 9, and there's already a natural 9 in that box. So this would be a 1 or an 8. If it's an 8, it's mirrored, so these are natural. And this has to go into a naturally small digit in one of these 3 cells. That's not too hard to do. Those cells can be a lot of things. Or sorry, naturally high digit. I apologize. This is low in this timeline. So naturally high digit in one of those three, which is not a 9. It would be a 6, 7, or 8. 7 or 8 there, 6 or 8 there. Yeah, that's too possible. Actually, well, if this was an 8, actually, then 8 is not an option in these. So this would have to move into a 7 here, a 7 here, or a 6 here. Can't move into a 6 there, because then you would have to move into a natural 1. Or not even that, just an 8 mirrored can't move into a 6. So it would have to move into one of these two. Golly, okay, that is complicated. I don't think I could disprove that either, unfortunately. Huh. How hard is this puzzle? This is 3 stars, so this is not ultra difficult. But it's supposed to be a little challenging. And yeah, I feel challenged, for sure. Let me think about the teleporters real quick, because remember teleporters, they must all have different digits, and the digits in both sides of the teleporter must be the same. So what can this be? This can't be a 1, 2, 3, 4, 5, because that's a 5. This could be a 6, 7, can't be an 8. This could be a 6 or 7. So this can be a 6 or 7. What about this one? This can't be a 1, could be a 2. Can't be a 3, couldn't be a 4, couldn't be a 5 because of that one. Can't be a 6, could be a 7, can't be an 8, can't be a 9. So this, well, there we go, actually. This can't be a 2 or 7. So this teleporter is value 3. So we found something at least. Which is progress, for sure. 3 is in one of these 2 cells by Sudoku. 3 is in one of these 2 cells by Sudoku. That's not very useful, unfortunately. I'm gonna be honest with you on that one. How long have I been recording? 47 minutes. Not bad, honestly. Let's think about this. What is going on? What is going on here? If this moves right, then it goes into a naturally high digit. That digit is an 8 or 9 by Sudoku. If this moves down, it can't be an 8, 9, or 6, so it'd be a 7, or it'd be a mirrored 4. Yeah. But then if it's a mirrored 4, its value is 6, so it needs another 1, which is not going to happen. So if this goes down, this goes into a 7. If this goes right, what did we say happens? It goes into an 8 or a 9. If this goes down right, this goes into a natural, can't be a natural 6. Could be a natural 6, actually. If the other digit on the other side of this natural 6 is a mirrored 9. But it can't be, because none of those can be mirrored 9s. In fact, we already have a mirrored 9, my bad. This can't be a 6. It is an 8, or it's a mirrored 2. That's too many options. And all those seem possible, unfortunately, so far. Let's do some pencil marking while I think of a way out of this. Because I just saw the 6, 7 pair here. So these are 1, 2, 3, 4, 5, 6 and 7 are taken 8. So that's not a 4 or 5, that's not a 1, that's not a 1. And that's not a 4. That is not as useful as I thought it'd be, to be honest with you. One of these is going to be a 5, it can't be on the path. One of the teleporters is probably going to be on the path, because they're in the puzzle, so I imagine that they're going to be used somehow. I'd be surprised if they were not, in fact. But what the heck is going on? Let's mark these ones, maybe. 1, 2, and 3 are taken. 4 is left. 5, 6, and 7. That can't be a 7, that can't be a 5. 5 is in one of these two, down here. Which means by Sudoku, 5 is actually there. Okay, there we go. That's something. And now there's a 1-8 pair, so that is a 4. Okay. Now, 4 has already been mirrored, so this can't be mirrored, so this is safe. And so this is mirrored, because all the other cells in this row are safe. So this is a mirrored cell, actually. And it can't be a 1, because 1 has already been mirrored. So that is an 8. That is a 1. These are safe. This is safe. Okay. Let's see. What numbers have been mirrored now? 1, 2, 4, 5, 8, and 9. So the numbers that are left are 3, 6, and 7. 3, 6, and 7 are left to be mirrored. Well, I can tell you which box the 3 is mirrored in, because it's not here, because none of those can be a 3 by Sudoku. And it's not here, because none of those can be a 3. So there is a mirrored 3 in there. Not sure how to mark that, but yeah, the 3 here is mirrored. So the 6 and 7 are mirrored down here. If the 7 is mirrored here, it goes there. If the 6 is mirrored here, it goes... I don't know. Could go anywhere. The mirrored digit here is a 6 or 7. The mirrored digit here is a 6 or 7. So there is a 6 or a 7 here, which together with this kind of make a pair. So that is a 4. Which is something, for sure. The digits left in this box are 1, oh, there we go, 1 goes there. 2, yeah, there's a 2 left. 3, 6, and 7, yeah, there we go. Okay. Well, maybe now, okay, yeah, now I can, okay, this can't move down, because this is a 4, and this has to go into another 9, which it definitely won't be able to do. So this goes right. And then this can't go there, because that's a 5. If this goes here, then that's a 2. Or it could go down. This path is inaccessible because of that 5. But we must get into this box somehow. So we're either going to get there through here, here, or here. I don't know how yet. I'm not sure how. I think it's not here. Because if it is, then what's going on? Then we either move from here, we go left. No, that actually works. Wow. That actually works if that's a 7, and then we go here. Wow, that actually works. My bad. So no, this is possible. If this is a 2, 7, 1. Dealio. Oh, but no, but that can't happen because this is a teleporter. My bad. Then we'd be thrown out of this box. So never mind, we can't go here. So we would either go there, which 4 doesn't fit with either of these digits. So we'd go there, which this is a natural 1, so this would be a natural 6. But then this would force this to be a natural 1, which it can't be. So I don't think we come in through here. I think that path is closed off. Which means we either do that and then go up, or we do that and then go up. Well, actually we do neither of those, because that's a teleporter. Ah, I didn't think of that. There is one other way into this box, through the purple teleporter. I was trying to prove that we pass through this 3, but that would actually be bad, because then we'd be forced to go here, and that would be a 7, and 3 and 7 just don't work. So we don't pass through this 3. I think. Well, we might, but we don't do this. We don't go up from that 3. So now, I think the only way into this box is through the purple teleporter. And now, the purple teleporter is a 6 or a 7, so it must connect to 2 low digits that are either 1 or 2. So it must do that, I think, which makes that a 2, that a 7, and that breaks the puzzle. Very good. Okay. So I did something wrong, for sure. But what was it? Jeez, okay. Well, that is definitely correct. We can't do that, because that's a 5. That's never gonna happen. We can't do this, because that would be a 3 and that would be a 7, and that just doesn't work. So that is not going to happen. If this happens, then this can't happen, so this would be forced to happen, but that can't happen because this is a teleporter. So I don't think this can happen either. So how is it not the case that, oh, it's because this is a teleporter, so it doesn't have an entrance and an exit. Girl, Jesus. Okay. I'm losing it, actually. This is a teleporter, so somehow I drew that. That doesn't make any sense. Now what does make sense is that from the teleporter, we're not going out right. Because then this would be a 2, because this is high, so this would be a 2, but now the next digit needs to be high again, and neither of these are high. So we don't do that. We don't do this, because 4 can't connect with a 6 or a 7, so we do that. Okay, that's correct. Yeah, that's good. From there, we need to go into a high digit. It can't be that one, because then we're stuck. Can't go anywhere. Could be that one. But then from there, we need to go into a low digit. And we can't go down, and we can't go... Oh, we could go there, actually. My bad. In fact, that's what's going to have to happen, because this is a low digit. Okay, yeah, that's correct. My bad. That's a 7, that's a 2. Not a 2, a value of 2. My brain is just not working today. Okay. This is why I need to mark these. So that's high. That gives us a 6 and 7 there, 6 there, which means that's a 6, that's a 2, that's a 5, and that's a 7. Now, 5 is not mirrored, because 5 has already been mirrored, so the 7 is mirrored. That is safe. These are safe. One of these is mirrored, and it is a 6. Well, this can't be a 6, so that is the mirrored 6, and that is the mirrored 3. So that is not mirrored, that is mirrored, and these are both safe, and that is mirrored. Okay, very good. So now we know where all the mirrored cells are. Okay, now what is left in this column? It is 6 there, and a 9 there. What's left in here? It's a 2, 4, and 8. That is a 4. What's left in this row? It is a 1 there, and a 9 there. What's left in here? It is a 2 and an 8. Left here is a 5, 7, and 9. 5 goes there. 7 and 9, like that. Here we have 2, 3, 4 right there, and a 7 right here. And then left in these 4 cells is 1, 2, 3, which actually goes there. 4, 5, which actually goes there, and 8. So we have these impossible pairs here, which we're somehow going to have to solve by completing this path finally. Now, we know that this is part of the path, so I'm going to color it red. From here, we're going to have to go into a natural 1, right there. So that is low. From here, we're going to have to go into a high digit, which might be that one, because that is high. That is value 7. Or it might be that one, and that would make that an 8. I don't know yet. Let's check out this part of the path instead. Yeah, okay, we can't go here, because that's a low value. That actually has a value of 3. We can't go here, because that does work, but then we have to go into another one, and that's not going to work. So we go there. From there, we need to go into a low value. Which, how's that going to work? Oh no. Oh no, am I stuck? I'm correct so far, right? Yeah. Oh no, how do I connect these two parts of the path? Oh no. That can't be good. That's not gonna happen because that's a 5. That has a value of 3. We don't use this teleporter, I don't think. Because if we do, then something needs to lead into or out of it. And it's not there, there, or there. It's not there. It would have to be there. But then something needs to lead in or out of this, and it would have to be there. So both of those would be forced to be 8. And that's not going to happen. So this teleporter is not used, I don't think. Okay. How long have we been recording? An hour. Okay. So what the heck? Am I missing something like obvious? Let's have a difference of at least 5. Not separated by teleportation. Yeah. Physically adjacent digits. Yeah, okay. That has a value of 7. If that has a value of 7, it would then have to move into a natural 2, which is in one of these two. Then that would have to move into a big digit, which is one of these two. Maybe, okay, maybe I mark how the path moves, like in big terms, and then I can figure out bottlenecks, maybe. Because from here, we're either going to go down, and that's an 8, or we're going to go here, because that's a value of 7. So we are going to go into one of these two cells. From those two cells, we might take a detour here, but we're going to end up in these two cells somehow. Because that is high. High. Oh, my bad, actually. Oh, we don't go down. Okay. Yeah, we don't go down, because then that's an 8, but then that has to move into a low value, and none of these are low values. So we actually do go there. And now that has to move into a 2, either here or here. I don't know which. But from there, it's going to move into a high digit, and that's one of these two. So we're going to end up in these two somehow. From there, we need to move into a low digit. And that's going to be either this or this. Hold on. Maybe, okay, maybe I mark which cells can't be on the path ever. Because I'm looking here and I'm seeing a few. This can't be on the path. Because this is a value of 4, so it would have to move into 2 9s, and there's not 2 9s adjacent to it. This can't be on the path. Same idea. This can't be on the path. Same idea. So that is going to be on the path. Okay, yeah, that's useful. Because now we need to move up. And there we go. That solves it, because that's low. So that's high, and that's low. And that's actually going to do it. But we're not done yet. We still need to draw the rest of the path. From here, this can't go left, because that's a 6. So it must go up. Or, no, it can't go up, because then it would move from high to high. So it must go directly here. This can't go there or there, because that doesn't work by German whispers. So it must go there. And then this is a 9. So this can't connect directly there, because that would be a 9 connecting to a 7. Can't go there or there, so it must go here, and then this connects there. And that's the path. Okay. That was cool. I like that. That was very good. That was not super hard, in fact. But it was very, very good, as usual. Let me draw just the rest of the coloring, because I might as well. Yeah, there we go. So yeah, you can see the alternation between green and red on the path. And you can kind of see the oranges. It's a little crowded, not gonna lie. But it's the best I could do. There might have been a better way of coloring it, so there wouldn't be as much clutter. But I mean, I can understand what's happening. So it worked out. That was very fun. I enjoyed that immensely. As usual, these rat run puzzles are amazing to work with. But finally, let's read out the blurb here. Experiment completed Experiment completed successfully. Cells visited 45. One-way doors used 1. Teleports used 1. Thankfully, the teleport that Finks used today behaved perfectly, with no overheating problems at all. With any luck, Elliot has fixed whatever was causing the issues. Finks seemed very interested in the mirror cells, stopping to investigate her own reflection at each one she came to, sometimes pawing at the glass. There's definitely something on her mind, and next week we aim to find out what. Just about an hour. Very good. I enjoyed that. Very, very much. These puzzles are sick, man. These puzzles are sick. These puzzles are sick, is what they are. Very, very fun. I like them very much. That was cool. That was cool. I very much enjoyed that. I've never worked with these mirror cells before, but they're an interesting idea. I like them. I like them a lot. Yeah. Very interesting. Cool. Let's enter a solution, shall we? Let's see. Digits on the path in column 7, reading downwards. What do we got? Column 7 has 179. 238. 179, 238. And if my computer will work. I actually do know why it's going so slow. I'm uploading a big video on a completely separate thing. But yeah. Oh, I didn't read this, by the way. Yeah, I keep forgetting to read these like starting blurbs. Elliot spent the whole evening at his desk scribbling away in his Phase 3 notebook, so that's what I meant, Phase 3 is pretty much confirmed, that he keeps locked away in the bottom drawer. I have no idea how he expects me to keep on preparing these mazes when he remains so secretive about the overall plan. When the time comes to construct the big one, I'll need to... So... can't wait for the big one. But yeah, we have 2 upcoming puzzles here. Brainwaves and Gifted. Pretty cool, pretty cool. Gifted will happen on Christmas Day, which unfortunately means I will be with family. So I might do that one quite a bit later. Family leaves. I don't know why I'm saying these things on video, but, you know. I'll do it in January, okay? I'll do it like beginning of January. Is what I'm talking about. But yeah, there we go. That was fun. I like that a lot. Again, probably a better way of marking the cells so there wasn't as much clutter. But honestly, it helped me. It helped me figure out what things went where. That was good. I enjoyed that. Well, that's it. Good night.